Hello and welcome to this SOFiSTiK tutorial about the cross-member functionality in the SOFiSTiK Bridge and Infrastructure Modeler. In this video, I will show you how to create a cross-beam family that you can use for your projects. What is the speciality of the cross-beam? In this case, this cross-beam will consider one adaptive point. This family will then be placed in between certain placements along our axis or certain stationings within an interval of 2.5 meters. And additionally, I want to modify and control the width via a station-based variable of our axis. Let's start by opening Revit and creating a new project. You can use the construction template which is provided by Revit. Now I want to go quickly to the 3D view and create a simple axis via the SOFiSTiK Bridge and Infrastructure Modeler. Click on Axis, Create, and the standard template opens up, which already gives me a little bit of information about the horizontal alignment of the axis as well as some placements. The standard is fine, the focus today is on the cross-member family. So next up, I want to create a new family. To do so, I come back to File, New, and click on Family. The program now asks me which family template I want to use, and for generally all SOFiSTiK Bridge and Infrastructure Modeler families, it's fine to use the metric generic model adaptive. So select it and open it up. In here, the program now is depending on which direction we work from. Keep in mind, with the SOFiSTiK Bridge and Infrastructure Modeler, you always want to work from the left side. I'll show you in a second what that means, but just to get started, I create a new point element. I place it in the middle of my geometry and I use the align command to align this point to the center of our reference planes. This is not necessary, but I prefer to do it clean like that. And with a simple click on Make Adaptive up here, you now have this adaptive insertion point where our family will later be placed in relation to our axis. You can also see that there is a coordinate system in X, Y, and Z direction, and this is why we work from the left, because these directions determine which direction it will later be placed along the axis. The way you have to imagine it, we start over here with our axis, and the axis always moves in the local X direction of our beam element right here. The family that we want to create is rather simple. It's basically a rectangle. But as we want to, on the one hand, control the interval in which it's going to be placed, which is the amount of adaptive points with families that will be placed along the axis, this is done via the bridge modeler. So in the family itself, we don't have to bother with that. But what we want to bother with is the width development of our beam later on. This is a functionality we can simply access via variables of our main axis. But we have to create parameters within the family. Before we get started with the parameters, just a couple of details I want to share with you. First up, always save your family. This will allow you to select a name for the family itself. In this case, I just save it on my desktop and I will call it Cross Beam. Click on Save, and now the family has the according name. You can also check up here. Next up, you can give it a family type via the properties up here. And this family type, especially if you have a bigger project, just accelerates the process that SBIM takes by placing the geometry, because it always selects a type. So if you just select type 1, it doesn't have to determine a specific name. It just works faster. The couple of parameters we have here we can ignore, and what we want to do is create a new parameter. This new parameter is supposed to be an instance parameter, so it can be freely modified via our input and not via the type of the family. And in this case, I want to give it a name like width to the left side. It is discipline common, that's fine. It's a length and it will be grouped via dimensions. So here you can see where it's grouped. Next up, we also want to control the width to the right of our insertion point or our adaptive point. So I select width right. I actually made a little mistake. You of course don't want to modify, you want to duplicate. So keep in mind there are multiple functionalities down here, and I can simply set it to width left. I will also already assign a value to it, which is in millimeters in my case. So one with 2000 and one with 3000. Let's see how this will play out once we create our geometry. I click on OK, and now we have to create the boundary points for the volume that we want to create. This is based on reference planes, so I set the work plane to be the reference of our adaptive point going from left to right. But keep in mind to always reference the point itself, not the general plane. I click on point element, which will be my corner point for this volume later on. And I simply click twice in the middle of this adaptive point. The first click does not give us a warning. The second click warns us that there are identical points in the same place. Lines created from these points may not work as expected. This is fine. Simply because those 2 points that actually will create a line in between will not stay at the same place. You can see once I hover over this adaptive point, I can now select a reference point. You can always see what we are selecting down here. So Revit always selects the last created element first. We clicked twice with the point elements, so I have the last point here. And the way that we want to parametrize our geometry now is via an offset parameter. These parameters, again, can be accessed directly in the cross-member interface of the SOFiSTiK Bridge and Infrastructure Modeler in our main project. Let's click on this little rectangle over here, and now the program asks me which family parameter I want to associate with it, and I want to start with the left parameter. And here you can see the 2000 millimeters we assigned to the left are now assigned to this point. And because we are always working orthogonally with these offsets to the plane where this point is created, it is now created with this direct offset. I want to do the same thing now for my width to the right. And you might notice it didn't move to the right. This is because, of course, in reference to our adaptive point, this is sensitive to plus and minus. So what we need to do is to either create another parameter which simply multiplies this width with -1, or we input the value with a negative. Both of them are valid approaches. Just keep in mind, you as the user have to define what the family actually does for you. Alright, so far so good. So we have the width of our element defined. Now we want to create our rectangular cross-section. There are again multiple ways to do this. I will show you the approach in which I simply assign a length and a height to the whole cross-section. So I come back to family types and I now create 2 more parameters, which are both instance parameters of data type length, which I will call length. And I will copy this one and call it height. The length of my element is supposed to be 200 millimeters and the height will be 500 millimeters. At this point, I simply select the right plane of my reference points. So the offset from the origin point will already be considered. By using the tab key, you can select the right reference of wherever your mouse is pointing. So I want it to move to the front. So again, orthogonally to the reference plane, I now have to select the vertical one. I create one point. Again, this warning because the 2 points are now overlapping. And just because I want to be quick, I simply select a new work plane, select the second point, and create another point right here. You can see if I select the point element functionality and select a new work plane, it keeps this reference point element active. So I can very quickly select multiple points to be placed at multiple references. I now select this point once. Again, Revit will always select the latest created one. And by holding the Control key, I select the second one, and you can see and double check for yourself if the offset is set to 0, this is the newly created point. I assign the length parameter to it. And now basically to get a rectangular section, I select point reference once more and select the proper work plane of my first point. I click on set, select the horizontal work plane of the second point, and I repeat this procedure for all my sides. And now we are ready to assign the height variable. So I select first point. Keep in mind you can also zoom. Holding Control, I simply select all 4 points and assign my height parameter to it. Once more, here you now see that the coordinate system is sensitive to plus and minus. These points were created in reference to these origin points, meaning that the coordinate system of this point is relevant to the offset. I can simply come back to my height parameter and set it to negative. Or I will show you the second option here. I can create a new parameter, which I will call negative h. Also set it to instance parameter, and I select height to be the source for the formula. And here I can set it to minus height. And instantly with this input, this parameter will be filled, and formula defined parameters will not be accessible via the cross member functionality. So we don't have to bother much. It will always assign the right parameter here. Now we have to come back to our points, select them, assign them our negative h parameter, and instantly we get the proper cross section. Now, last but not least, as typical for these cross sections, we select only 2 of them and we spline together the proper points to now create our rectangle reference for the geometry. So I select 2 points, 2 points, 2 points, and here we go. Maybe a quick side note, these reference lines that will not have their own functionality or geometry importance, we can just select them and set them as reference line with not a reference. So if you insert them, they will not catch your mouse as a reference. Now you can select these 2 reference geometries and tell the program to create a solid form. And that's the whole magic about creating this cross-member family. Again, one adaptive point. Width is controlled via parameter on both left and right side. We have the height defined with a parameter as well as the length. Now it's time to load it into our project. You can see now the family is available in this project. And when we go to crossmember and create this along our axis, we can instantly find it selected here as our cross beam, type number 1. You can also find our height, length, the width to the left and the width to the right as variables that we can access here. Additionally, I will just start by creating it at every single placement, which means that now one of these families is placed at each placement. This is not necessarily what we want, so we can always come back and edit it and unselect 2 of these placements. Let's just have it in the last 2. Because now what we can do, instead of placing it only at the placement, we can tell to the program that in between those 2 selected placements that we have here, we want it to also be created in between those placements. You can see that the pre-selection is maximum spacing, starting from the start of the first placement, measured by the curve parameter, and the spacing will be 2.5 meters, or in this case 2500 millimeters. I click on OK, and the program instantly gives us the desired result. This again is simply achieved by having one adaptive point and having a volume attached to this adaptive point. Now I want to add additional complexity to this axis via variable. So I come back to the axis, I select it and edit it. Here in the second drop-down, so the first drop-down tells us about the alignment, the second drop-down allows us to add variables. I can simply create a new variable called R for right. Remember that the right side is to the right of the coordinate system of the family, and this is also true for the axis coordinate system, meaning we have to define our variable in minus. I also only want to be created in between our placement 90 and 150, and what we can do is we can simply create additional values here. So these values should be defined at 110 meters. I create another one at 130, and the value should start at minus 4000. Up here it should increase to minus 5000. In the end I also want to have minus 5000. And in the middle here I want to have minus 2000. You can see that these values are created as a polygonal development. Let's actually just click on OK and check the changes that we can achieve by coming back to editing the axis later. Click on OK and nothing happens. This is because before the crossmember knows what to do with this variable information, we have to assign it to a parameter. So I come back to the crossmember family. Now I tell the program that the width to the right should be variable instead of a fixed value. And I can select variable R right here. Click on OK, and the program immediately showcases the changes. We can either align the 3D view, or we could even create our plan view to check these values. By the way, in here you might need to unhide these elements, and you can see that the development is linear. We can also change this to be a little bit more versatile simply by coming back to the axis, variables, and change the polygonal development to a transition left and right. What does this do? Tells the program that at this point there should not be an angle available. So to the left and to the right we have the angle development, but here we have a horizontal tangent. Click on OK, and the change is immediately applied to our crossmember.